Okay, question 3. If sine 17 degrees is equal to a over 1 without using a calculator, express the following in terms of a, and then I gave you a hint as well. Draw the triangle. So before we start answering, let's draw that triangle. So they said sine of 17 degrees is a over 1. Okay, let's draw a triangle. 90 over there, and our reference angle is 17, and what did I write here? A over 1. So opposite is a over hypotenuse 1. Then I use Pythagoras to find this adjacent side, so that's going to be a squared. Let's make it x for now. Okay, let me not write the x there, but let's make it x for now. It's equal to 1 squared. X squared is equal to 1 minus a squared. Then I need to square root, so that's 1 minus a squared. So this is the square root of 1 minus a squared. Okay, right. So 3.1.1. Now I can answer my questions because now I have all the information over there. Also, before we start answering, so if this is 17 degrees, so if that's 90, that means there's 90 degrees left. 90 minus 17, that would make this angle 73 degrees. Okay, so 3.1.1. We need to express this in terms of a. This one is fairly straightforward. Tan of 17, I'll just go to my triangle and read that off. So tan is opposite of adjacent, so that would then be a over the square root of 1 minus a squared. Right. 3.1.2. Sine of 107. So I can say, do some reductions there. 180, that's the same as 180 minus 73 degrees. 180 minus 73. If I reduce that, so 180 minus 73, that is in the second quadrant where sine is positive. So that reduces to sine of 73 degrees. And then I go read off here. Sine of 73 would be opposite of hypotenuse. That would be square root of 1 minus a squared over 1. And then 3,13. Cos of 73, also straightforward. I just go read off what cos of 73 is. That's adjacent of hypotenuse, which is a over 1. Okay, 3.2. In the figure below, the point P is -5 and B is plotted on the Cartesian plane. OP is equal to 13 units. OP is 13, and ROP is alpha. Okay. Right. So, without using a calculator, determine the value of B. Okay, so if P is -5B, then -5 is the x coordinate, so it's that value there, and then this vertical one is B. So without using a calculator, determine what B is, so I can use Pythagoras. So basically what I have there is this. That's O, that's P. Okay, that's all I have. So that's 13, that's -5, and P is over here, so I can use Pythagoras and solve that. Okay, so that would be -5 squared plus B squared is equal to 13 squared. B squared is equal to 13 squared minus the -5 squared. b squared is equal to 13 squared is, I should know this, 169. 169 minus 25, and that is 144 square root that is equal to 12. So b is equal to 12. Okay, right. So that was 3.2.1. 3.2.1. 3.2.2. Cos of A. Né? So important to note, if this is alpha, that is also alpha in my little triangle. Né? That's alpha over there. So now I can just from my triangle, I can read off cos of alpha. So cos is adjacent of hypotenuse. So that's negative 5 over 13. And then 3.2.3 tan 180 minus alpha. So again, reduction. So 180 minus theta, if I look at my quadrants, 180 is over here, right? 180 degrees minus some acute angle, which is alpha. So that's going to land me in the second quadrant. And that's where sine is positive, not tan. So tan would be negative if I reduce that. So it's negative tan alpha. And then I go back to my triangle and read off what that would be. Tan of alpha. That's opposite over adjacent. B was 12 now. So that would be negative 12 over negative 5, which is just 12 over 5. Okay, sorry. Okay, let me pause there.